So I promised that we would do stochastic banded arms, deterministic MDPs, and then ultimately combine ideas together and handle general stochastic MDPs. So I think we can do efficient exploration of deterministic MDPs relatively simply, actually. Here's a little randomly generated MDP, randomly generated in that I drew a bunch of arrows, and I have absolutely no idea what the solution to this is. But if we were doing reinforcement learning in this MDP, all we would know at any moment in time is which state we were in and which action we were choosing. And so an action in this case would just have a label like action 1 and action 2. I made 2 actions for each of these states. You know, we know how to solve a deterministic MDP to figure out the optimal policy for it. But we can't solve it in the beginning because we don't actually know any of this stuff, right? All these numbers, where do the arrows go and what reward do we get on an arrow? We don't know any of that at the beginning.
Right. So 2 observations. 1, you don't have 2 actions at every state.
Oh, what do you mean?
Well, the one that has a 3 coming out of it, there's only 1 action that comes out. You don't have a self-action.
This one?
Yes.
Dope. All right. There's just 2 things. They both have a +3. But you're right. I thought I got them all, but I missed that one.
Doesn't really matter. So that's one observation. One observation is 1 does not always equal to 2. The second observation is that if we know it's deterministic, then all we have to do is in every state try every action once.
Yeah, that's true.
And then we know everything we know about which action is best or whatever. Magic. Something like that. Shouldn't that work?
Okay, well, you're kind of onto something. It's certainly the case that once we've tried each action in each state, then we can actually build the entire MDP and solve it.
Right.
The question is, what do we do along the way? What do we do when we don't have the whole MDP yet? Maybe it's not entirely clear. I mean, if we could just teleport ourselves to any state that we wanted to be in and take the action at that state, then that would be fine. But that's not how the world is in reinforcement learning, right? We actually are, all we can do is choose actions. We can't choose which state to be in.
Well, we could track every state that we've ever been in and every action we've ever taken.
That's true.
And then just, do things that seem reasonable, explore a little bit randomly so that we make certain we get to every state and get a chance to take every action and then kind of go.
All right, so you're thinking explore randomly so that we hit everything. That could work, but we can make MDPs where that's problematic because if we choose actions randomly, we keep, for example, getting reset to some beginning state and actually not choosing things randomly so that we visit all the states can be challenging.
So that's true, Michael, but if we don't know anything about the MDP, then I can always construct, an MDP that's going to mess with whatever exploration strategy you have, right? Because there'll be some state with some action that puts you into some state you can never get out of. So unless you can do random restarts or, be able to get to some state, press a button and do a reboot, you could always get unlucky and never be able to explore the MDP.
Okay. All right. Well, that is a fair point. We have to be very careful about what we think our criterion is. Now, we went through it pretty carefully in the case of bandits, but I kind of jumped to deterministic MDPs without revisiting this question. So I'm gonna propose a particular optimization criterion, and then we'll talk about why it needs to be like that.
Okay, that seems fair.